Suppose now that I wanted to give Scratch the ability to sneeze as well. Well, my first instincts would be, as before, to make a block, call this sneeze, specify that I'd like to specify with a number how many times Scratch should sneeze. Thereafter, clicking OK. Let me move this over to the right to give myself some more room. And then let me again go to repeat, overriding the default 10 with n. Let me go to the say statement and say not hello, but achoo for 1 second, then take a moment's respite. And that's it. Now I have a block called sneeze, as well as a block called cough, so that now if I want Scratch to cough and sneeze, I can simply specify a sneeze below his cough 3 times, say, click the green flag, and I should see indeed cough, 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 followed by achoo, achoo, achoo. My most realistic sneezes to date. Now, notice something that's bad about this design. Even though I didn't outright duplicate any puzzle pieces, I definitely dragged and dropped pretty much the same puzzle pieces, giving the one function an ever so slightly different name than the other, sneeze versus cough. So this is an opportunity for factoring out some common code. Indeed, notice the only difference between cough and sneeze is that one has Scratch saying cough, the other of which saying achoo. So couldn't we somehow generalize this code in such a way that we simply specify what word we want Scratch to say, and depending on that word, it will effectively be a cough or it will be a sneeze. So let's go ahead and do this. Let's make a third function and call this one say. And I want it to accept not just a number, but this time a string, otherwise known as a word or a phrase. And we'll call this word. And how many times do I want to say this word? Well, let's specify a number, calling it again n. And just to make this block more readable, let me go ahead and add a label called times, so that when you read this block from left to right, it literally says say word n times. Now let me go ahead and click OK. And now let me implement this block, again using a repeat block, specifying that I want it to repeat n times, specifying that I want to say something for 1 second, but rather than something hard-coded into this function, let's instead drag and drop the word that's been passed in. Let's then wait for 1 second. So now let me go back and refine my implementations of cough and sneeze in such a way that those two functions call this third function, thereby minimizing the amount of duplicate code. So let's literally throw this code away. Let's throw this code away. And this time, let's simply specify that cough should be implemented by saying cough some number n of times. And similarly, can we go back and re-implement sneeze so that it uses say with an argument of achoo n times. So what have we done? We've recognized the code that was common to both our cough and our sneeze functions, factored it out into a new third function, and then rewritten cough and sneeze in such a way that they call that third and new function. Now, we have absolutely made this whole program more complicated than it really needs to be. After all, at the end of the day, we just need Scratch to cough 3 times and sneeze 3 times, and we could have done that with just a few puzzle pieces. But as our programs get much more complicated and our programs more sophisticated, this technique of factoring out common code, or hierarchically decomposing your program into smaller functions, each of which call other functions, is a very compelling technique because it will ensure that your code, even as it gets more complex, remains easy to update and also very readable. Indeed, consider the end result. When the green flag is clicked, cough 3 times, sneeze 3 times, and that's it. In fact, let's do exactly that. Click the green flag, and we get 1 cough, 2 coughs, 3 coughs, followed by, we hope, 1 sneeze, 2 sneezes, and a 3rd sneeze. Hope he gets better soon.